In this video, I will talk about the derivative of the function at the point a. Definition of the derivative. The derivative of the function f at the number a is denoted as a f prime and is equal to f prime at a equals to the limit as h approaches 0 of the ratio f of a plus h minus f of a over the h, if the limit exists. We may also have a different form without the h, like just using the x, f of x and f of a and a. And the other form looks like f prime at a equals to, as a limit, as x is getting close to a, and the ratio is f of x minus f of a, x minus a. That means we know that this is derivative of the function at the point a. The formulas came from geometrically we defined a derivative of the function as a slope of the tangent line. That means we may try to just prove this. I can draw a function, possibly something like that, f of x, and I would like to find an equation of the, just the slope of the tangent line at the point a. That means that's the tangent line. But we can see, in order to find the slope, I need 2 points, because I need rise over run. I have only 1 point. That means we will create another point, and I will move just h units from a, which this will be a plus h. This difference along the x-axis is h. Then I do have a second point, which is the value of the function for a plus h. Now I can create a line which goes through these 2 points, and of course is secant. In order to find a secant, I need the slope of the secant, I need delta y over delta x, but delta x of course is h. Slope of the secant is just difference along the y-axis over difference along the x, rise over run. And we can see, in order to find delta y, we simply need the difference between the top value, f of a plus h, minus the bottom one, f of a, all over delta x, which is h. That means we do recognize this is the same part. However, without this limit, it's just the slope of the secant. But if I would like to define slope of the tangent, I have to move this point really close to the point A. And this results h being extremely small. That means if h is extremely small, I can't say h is 0, because I can't have exactly that point. I have to be extremely close. That means as h is 0, the situation is the same, but I have to indicate that h is 0, almost 0, and then this formula together with the h definition means the slope of tangent line. That means graphically, please remember, derivative means slope of the tangent line at the point a, f prime at a. And we also learned that this limit has a lot of application. That's the reason that we have a special name, derivative, and special notation prime, f prime. Okay, that's me. Now let's see. Find the derivative of the function x squared at the number a. That means I know that the derivative is defined as a limit as h goes to 0, f of a plus h minus f of a all over h. Limit as h goes to 0, f of, actually I can substitute, I can evaluate. My function is defined as a x squared. That's mean now instead of x I have to put a plus h squared. minus, instead of x, a squared over h. Okay, that means this this limit represents the derivative of the function x squared. Let me write one more time. This limit represents the derivative of the function x squared, because we can see the quantity squared at a. And a, we don't have the exact value, it's just a. Okay, let's evaluate. Limit, actually I want the red color. Okay, limit sh goes to 0, and let's expand. A plus h squared means a squared plus 2 times ah plus h squared. Okay, you can write a plus h times a plus h and distribute all of the numbers. Minus a squared over h. We can nicely see this cancellation. And what's left? Limit sh goes to 0. We have 2ah plus h squared. H is a common factor. 2a plus h. And now I see another cancellation, really important, because this is my 0 over 0 if I will perform the direct substitution at the end. That means my 0 is gone, and derivative looks like limit as h goes to 0, 2a plus h. And now I can say h is 0. That means derivative of the function x squared is 2a at the number a, of course. And depends what the a value is. This means slope of tangent at a, at the point a. Okay, but one more time, quite important thing is this one, to recognize if you will see this green box and if you will have a question, what function, this limit represents the derivative of what function, you have to recognize that is x squared at a. Okay, let's do another one. Maybe this one, I will change one thing and I will say, let's find the derivative at 4. That means my a value is 4. Just to have the exact point. Okay, find the derivative of the function f of x equals to square root of x at the number 4. That means I have to start with my notation. Derivative at 4 is defined as a limit as h goes to 0, f of 4 plus h minus f of 4 over h. Let's evaluate for our function. Limit as h goes to 0. Function is defined as a square root of x, but instead of x, I have to put 4 plus h minus square root of 4 over h. And if I substitute instead of h 0 now, I'm getting 0 over 0. Of course, because that's the point of that limit. It's rise over run. 0 over 0 is the slope of the tangent line. Okay? But again, let me point this. This limit represents derivative of the function, and we can recognize square root of x at 4. Okay? And let's evaluate. We remember that having radical expression in the limits, we can multiply by the conjugate in, like, if we would like to simplify or rewrite. This means square root of 4 actually is 2. Mean I will multiply and divide by the conjugate expression of this root term. Square root of 4 plus h and 2, and instead of minus I will add, because that's the conjugate expressions, always opposite, plus 2. And the 2 conjugate we have to distribute, but we will keep the denominator in the product form. Limit sh goes to 0, and my denominator looks like h, square root of 4 plus h plus 2. And if I will FOIL the numerator, I have to square the first quantity, which squaring the square root, I am getting rid of the square root, and minus the second quantity squared. 2 squared is 4. Okay, I see some simplification. It's me now. Limit. You probably think, why we have to write the limit all the time? Please remember, without the limit, it's not a derivative. It's not a slope of the tangent line, it's the slope of the secant line. That means we will definitely misunderstood the concept. H, and I can copy the rest of the term, and we can also see h is gone. H is a common factor, h was the 0. Now the limit sh goes to 0 of the function 4 plus h square root plus 2. And now I can substitute instead of h0. 1 over square root of 4 plus 0 and plus 2. Square root of 4, of course, is 2. 2 plus 2 is 4. This is a derivative of the function root x at 4, 1/4. And of course, this means slope of tangent. Tangent at 4. For the function, slope of the tangent at 4 root x. I can draw this just to show you graphically. Okay. That means this is my function square root of x, and if I would like to find a tangent at 4, this is that line, and slope is 1/4. That means if you will have another question, what is f prime at 4 for the function square root of x, you have to find the derivative. It's 1/4. It's the slope. Okay? It's not 2. Okay, one more like that, and then another type of question. Find the derivative of the function 1 over x, and maybe the same, let's say maybe at 2. Okay, that means a is 2. Actually, I can write a little bit nicer, at a equals to 2. Okay, derivative of the function at 2 equals to limit sh goes to 0, f of 2 plus h minus f of 2 over h. Let's evaluate for the given function. Function is defined as a 1 over x. That means 1 over 2 plus h. Instead of x, 2 plus h. Instead of x, 2. Excellent. That means this limit, before I start evaluating, this limit, if you will see this type of limit, you have to recognize that this is derivative of the function. And we can see 1 over the quantity, 1 over x, at 2. Okay? Hopefully you will remember this. And again, doing the direct substitution, if h is 0, I have 1/2 minus 1/2. This is 0, and h is 0. That means 0 over 0. Again, it makes sense concept-wise because it's slope of the tangent line. Okay? Rise over run. We're not moving anyway. It's just the tangent, 1 point. But we know that we can still evaluate this. Let's find this common factor, this common 0, cancel out, and hopefully we can get the slope. Okay, what I will do for this one, I will get a common denominator on the top. That means the common denominator is 2 times 2 plus h. 2 times 2 plus h. And the first fraction I multiply by 2. That means I'm multiplying and dividing. The second fraction I am multiplying and dividing by 2 plus h. Okay, Still a few steps. Let's rewrite this as a one fraction, 2 plus h, and is 2 minus 2 plus h. And maybe, actually, I will change a little bit. Dividing by h means multiplying by the reciprocal. That means, let me write this way. Okay, that's my numerator, and dividing by h means multiplying by reciprocal. Then I can save one more line. Limit as h goes to 0, and let's see, 2. I am going to distribute a negative, of course, negative 2 minus h. 2, and maybe I can multiply by h, 2 plus h. I can switch the order. 2 times 3 is the same like 3 times 2. Limit as h approaches 0. Okay, some cancellations. This is gone. Excellent. Negative h, 2h, 2 plus h. And now we can all see h and h gone. 0 over 0. Okay, limit as h goes to 0, negative 1, 2, 2 plus h. I believe now I can try the direct substitution. Negative 1, 2 times 2. Negative 1/4. This is slope of tangent line at 2 for the rational function 1 over x. I can also draw this situation for you just in case. 1 over x looks like that, and the point 2, it's somewhere here. That means slope, we have value 1/2. Slope, of course, is negative and 1/4. Value of the derivative at 2 is the same thing. Okay, we know that's the derivative slope. Okay, now let's look at this exercise. Now this exercise will test if you really understand the concept of the derivative at the point A. That means each of the limit represents the derivative of some function f at some number a. State such a function and the number a in each case. That's what we can see. Limit as h goes to 0, quantity 1 plus h to the power of 10 minus 1. I am assuming that is the same pattern, 1 to the power of 10 over h. That means this represents the derivative, and I can nicely see the value a is 1. Derivative at 1, but what's the corresponding function? Quantity to the power of 10. Yes, we can see 10. I mean x to the power of 10, x to the power of 10. Okay, the second one looks like limit as h goes to 0, 1 over the quantity, 2 plus h minus 1/2 over h. We actually did this. It's the derivative at 2. That means I can maybe write the a value. Derivative at 2, and the corresponding function, it's 1 over the quantity, which of course is 1 over x, and a is 2. Okay, limit as h goes to 0, square the fourth root, I was gonna say the square root, the fourth root of the quantity 16 plus h minus 2. That means I'm assuming that this is also the fourth root of 16, which is 2. Derivative at 16, and looks like the fourth root of the quantity of the x, and a of course is 16. We can try to evaluate, but we don't have to. We only have to state the function and the point a. Okay, this one looks like a limit as h goes to 0, 2 to the power of the number. That means I will start maybe with this 2 to the power of x. It's actually exponential function, but it's not really difficult. That means this is derivative at 5. This is my value a, because this represents 2 to the power of 5, 2 to the power of a. At a being 5, of course. Okay, another 4. limit as h goes to 0 tangent of the quantity minus 1. And the quantity is pi over 4 plus h over h. That means this represents the derivative at pi over 4. Of course, that's my a value. And function is, I just said, it's tangent of x. And a is pi over 4. That means this one must be tangent at a, which is tangent at 45 is 1. Okay, respectively the same, derivative at pi. This is my a value. And then, this one we have to be really careful. Look at this, addition. Okay, that means I don't know if this is really derivative. It doesn't really match at the moment to my definition. But let's see. Normally we will say cosine of x at pi. That means this number, I can use different color to point the plus, and I can come back to my red. This is supposed to be cosine at a, cosine at pi. But cosine at pi is negative 1. That's when we're subtracting a negative. Everything works. That means this is still derivative at pi for function cosine of x. Okay, this one looks like derivative of e to the power of number. I can start e to the power of x. And a is 1 plus h. I mean, the quantity a is just 1. That means derivative at 1 of the function e to the x. And the last one, it's limit as h goes to 0, ln of the quantity. Okay? ln of a. And a is e. This means my function is just natural log ln of x at the value e. Derivative at e. Because this is ln at e1. Okay, that means make sure that you can also recognize a given limit definition of the derivative, and you can recover a function and the a value. And I have two more problems. Another one is find an equation of the tangent line to the graph g of x at the point 5. If this information are given, g at 5 is negative 3, g prime at 5 it's 4. Okay, that means what I need. I need tangent line. First of all, I need slope. And we know that slope of the tangent line, okay, it's simply a derivative. Actually, we do have function g. Slope of the tangent line is derivative at the given point. And that's this. That means this is slope of tangent. At the point 5, of course. That means I can write the point slope form of the line. Point slope form, which is y minus y1, slope x minus x1. And from this one, I can see that the value for 5, it's negative 3. That means that's my point. Y minus negative 3. And slope, it's simply a derivative at 5. And minus 5, because everything is happening at 5. Y plus 3. And my slope is 4. Oh, that's not 4. That's 5. Okay. Now I can subtract 3 from both sides, and I can distribute 4. Equation of the tangent line is 4x minus 23. Okay, that's tangent. Tangent line, of course, at the value 5. Okay, but we can see the most important thing was to recognize that this is a slope of the tangent. Okay, and the last one, if a tangent line to the function f of x at 4, 3 passes through the point 0, 2, find f of 4 and f prime at 4. F of 4 and f prime at 4. Okay, f of 4 actually we can see is the corresponding value. That means I don't even have to think, it's simply 3. Done. F prime means slope of tangent. of tangent line. Of course, at the point 4. But slope, I mean tangent line is just a normal line. That's mean maybe having 2 points, because I know that my tangent line goes through that point 4, 3 and goes through 0, 2. That means I can simply find f of b minus f of a, b minus a, because that's how my tangent line goes through 4, 3. That means one point is 4, 3 and another one is 0, 2. Let's compute. Subtracting 2 minus 3 and 0 minus 4. Negative 1 over negative 4. 1/4 is the slope of the tangent line because goes through these points, but also is, in our new understanding, is the value of the derivative of the function at 4. Okay? That's the slope of the tangent, 1/4. Okay? Make sure that you understand the concept from this section. You may